Hello everybody. In this second video of our Autodesk Cylinder, we are going to do our first operation milling for our cylinder right here. Before we get going with our milling though, what we need to do is we need to import all of our milling tools. If we go over to our manufacturing tab, so on the left hand side, top left corner where it says design, we want to click on that. We click manufacture, and then in kind of the center we have our tool library right there, and we'll pop up a window. Now right now we don't have any tool library in here. What we are going to do is we are going to go out and grab that. So we'll hit close on that, and if we open up our website, I'm on unit 4 where it says CAD CAM. We want to look for the RFHS tool library, which can be found right there, and when we click on that, it'll bring you to the Google Drive, and we will click download, and that is going to put the tool library into your downloads folder. So we can minimize that, and we can go back to our tool library, and where it says local library right here, what I can do is I can right click on local and I can import our libraries. What's fantastic with this is we have all of our tools set up. So we can click on your RFHS tool library, click open, and here are all the tools that will be that we have at our disposal. So just take a look at this. We have, in the first couple, we have our flat end mills, then we have a couple of ball nose mills, and then we have a whole bunch of drill bits. We have a 1/4-20 tap and a 1032 tap. We have a couple chamfer bits. We have a key cutter, and then finally, these are all for our steel. So it's a lot of the repeated stuff, except for steel. So when we're done with that, we can hit close. So before we do anything with setting up our mill, what we need to do is we need to create a setup. So in Fusion, we made this part. This is the final part that we want to do. This is not the aluminum that we're actually going to be milling out. So what we need to do is we need to start out by setting up or creating a setup for our aluminum. So on the left hand side in the browser where it says setups, we want to right click and select new setup. And I'm going to hit cancel here because I forgot. I want to just double check. If you are running Fusion and you had already from the previous video selected that we have our units already set in inches and you made that your standard, that will carry over to this. However, if you did not say that that is your standard unit of measurement, we want to double check before we make our setup that you have your units in inches. So again, how we change that is we highlight that, we click on the change active units, and if it were millimeters, we want to switch it to inch, make sure that it's set as default. So let's get back to making our setup. I'm going to right click on setup and select new setup. And here we are going to start off by selecting our operation, and that's going to be milling. We have a couple of different things. Your milling is what we're going to be doing in here. You have turning, which is what we'll be covering later on our lathe. We have cutting, which would be like using a plasma table, and then we finally have additive, and we can actually use this to set up our 3D printers. All right, for our work coordinate system, we can use our model orientation. If we set up the CAD drawing like I showed you, your model orientation will be correct. It will be absolutely correct where your Z's up, your Y is going back, and your X is going off to the right-hand side. If for some reason it is not like that, what we need to do is we need to absolutely make certain that this orientation is like that. To be able to change that, instead of model orientation, what we can do is we can select our Z-axis and plane and our X-axis. So what I'll do is I'll select that, and for our Z-axis, what I want to do is I want to select a line. So here's my vertical line. I can select my Z-axis for that. And then for my X-axis, I want to select a line or an axis that's going in my X direction. So I can click on that for my X. Now, if you notice, we have our X and our Z's on the right axis. The only problem is that it's upside down. So what we can do is we can either flip our Z-axis, but if I flip my Z-axis, that's not quite right. So what I'll do is I'll flip my X-axis and my Z-axis, and now everything is set up right. So what you need to do is, if you didn't follow the way I catted it up so that you have your Z, your X, and your Y done absolutely correctly, what you'll need to do is you'll need to go and you'll have to change your work coordinate system orientation and select your Z and your X axis, and then you'll have to flip one or the other or both to be able to get it orientated properly. All right, so our origin, what we want to do is we want to have a stock box point. So this is our stock, the little yellow brownish color. And my box point that I want to select is going to be our top left corner. So what's going to wind up happening is when I cut out this piece of material and put it in the mill, I'm going to grab my hammer and I'm going to zero in the X, in the Y, and the Z on the very top left corner of our part. So the next thing I'm going to do is I'm going to go over to stock, and I'm going to have a fixed size box. So the width of this is going to be 2.5, and I want to have that in the center. My depth is going to be 2 inches, and I want that in the center. And my height is going to be 1 inch. However, I don't want to have that right in the center. How we're going to machine this is I want to have my part closer to the top than to the bottom, because we're going to have our vise jaws gripping on the bottom here, and we want to be able to have our part as far away from those vise jaws as possible, but still be secure in there. So instead of having from the center, what I'm going to do is I'm going to offset from the top, so plus Z, and we're going to pull it down 0.02 or 20 thou from the top. So when we're done with that, we can press OK, and now we have our stock set up inside of our box of aluminum, and we can start running our tool paths. So the first thing that we want to do is we want to bring in a facing mill bit, and we want to be able to pull that off, the top off. So I'm going to go to face, and the first thing we need to select is our tool, and on the left hand side we want to go to our RFHS tool library. So in here we have tool number 1 is an 1.5 inch face mill, and we'll hit select. Now with this we have tool 1, and you need to make sure that this is tool 1 when we actually put this into the mill. So in our program, and we'll see this later when we look at the post-process, this is tool 1 with our length 1. So what we need to do is, when you are setting your tools, you need to grab your 1.5 inch face mill. You need to make sure that it is labeled as tool 1 when we're putting it into our automatic tool changer and when we set it. And when we set it, we also need to make sure that that distance, or that tool offset, is also associated with that tool 1. So with this, our speeds and feeds for our first couple are going to be just very stock, very slow, just to get comfortable with this. We'll be increasing our speeds and work a little bit more towards production in a little bit, right? So for our spindle speed, it defaults to 4,000, but we're actually going to change that to 3,250. And our cutting feed rate, our lead in, lead out, ramp, and plunge feed rate, those are all going to be at 20 inches a minute. This is going to be pretty slow, but we'll be all right for that. Okay. For our geometry, we don't have to select anything because it's just outlining our aluminum, or our setup box. For our heights, what we want to do for this is we want to change everything from our model top to make sure that everything is going to be the same. And our top height for our offset, what's going to wind up happening is, so our clearance height is when our mill bit comes down, we'll be able to do a rapid feed above that clearance height. Your retract height is when it's going to pop up and kind of move around a little bit. We have our top height is where the mill bit is going to start, and we cut down to that bottom height. So our top height, if we remember from our part, we offset it 20 thou. So your top height is going to be 0.02, or that 20 thou. So our mill bit is going to take off between that light blue line, which is that top height, and that dark blue line, which is your bottom height. So then we'll go to our passes. We'll be able to do this in one pass, a single pass. Our pass direction, what we want to do is we want to change that to 180 degrees so that when it comes in, it's going to come down and it's just going to take one milling pass. Our pass extension, we want that I'll change that to 0.76, because all of this, we go off of the center of your tool, and our tool is 1.5 inches in diameter. So what's going to happen is we want this to come down off of our part. So when it comes down, we want it a little bit past that halfway point, which is at 0.75, so we put it at 0.76. So we're back off a little bit. We're going to come on in, it's going to go straight, and it's going to come back up. Our step over, we have 1.5 inches bit, so our step over will go 1.4 inches. And our direction, instead of going both ways, we just want to climb mill the entire time. All right, we're not going to leave any stock to leave for this one, and everything there looks good. I am going to take off my lead in and my lead out though. So then we'll press OK, and we can see that now we have our first facing tool path. What I can do is I can right click and I can click on simulate, and we can see, I went a little bit quick, so we'll rewind that. It's going to come down off the part, it's going to come through, we'll speed it up a little bit, and it goes through twice. Alright, now that we have our first facing tool path done, we'll be able to start cutting out our next one. To do that, we click on 3D, we go down to adaptive clearing. And what this is a roughing strategy that will be able to pull everything out. We're not going to get all the way to the edges yet, but it'll do a good job of clearing everything out for us. So instead of our 1.5 inch facing end mill, we'll select our tool, go to our RFHS tool library, and select number 2, which is our 1/2 inch end mill. We'll click on select, and our spindle speed is 3250 for this one. And again, we're going to be taking very conservative, very nice and slow feeds for 20 inches a minute for everything. We'll go to our geometry, and again, this one is going to take into account everything that is within our piece of stock that we set up with our setup. Make sure that we have rest machining selected. What rest machining does for us is the computer calculates what material is left, and it'll only create a tool path on there. If we didn't select rest machining, it would want to face this part off with our 1/2 inch mill bit. But seeing that we already faced that with our facing bit, this will just take the inside contour of our hole right there as well as the outside right there. We'll go to our heights, and we want to make sure that we are going to model top for everything so that everything is all the same. And our top height, because we already faced this off, our top height is going to be right at our model top. Our bottom height, what we want to do is we want to go down a little bit further than what this part is. So our part was 0.78 thick. We're going to do an offset of -0.8. And we want to make sure that we're doing 0.8, not 8, because those decimals are very, very, very important. Right? Then we're going to go to our passes, and here our optimal load is going to be our depth of cut. This is another super important one. And for our optimal load for this first one, we're going to put an optimal load of 15 thou on there. So what this will do is this will take off 0.15 for every pass. Minimum cutting radius, that'll be good. Direction, we always want to do climb milling. So climb milling will give us a better finish as well as prolonging the life of our bit. We want to make sure we have flat area detection selected, and we're going to leave some stock. So this is our roughing tool path right away, and what we want to do for our stock to leave is we want to leave 5/1000ths of an inch, so 0.005. So your radial stock, or the radial is how much on the side, and axial is how much down. So it's going to leave 5/1000ths of an inch on the side and on the bottom before we're done. So we'll go over to our linking. Maximum stay down, 2.5 inches is fine. We'll just switch that to 1. Lift height. And for your ramp, we want to make sure that we have a helix, 2 degrees fine, and that all looks okay. So we'll press OK then, and the computer will do some calculations, and you'll see that we have our part. Okay. Now with this, it's going to be taking two passes on this if we want to do a full depth. And if we want to go back and if we want to edit any of this, okay, we can right-click on Adaptive 2, and we'll click on Edit, come back down to our passes, and if we come down here, we have our maximum roughing step down. So our rough was going down 0.8. So for our maximum roughing step down, I'm going to change that to 0.8. And press OK. It says that our step down is greater than the flute length. That's going to be all right for this because our flute length is actually longer than that. We have an inch worth of flutes on our mill bit. And now what we're able to do is we're able to take a full path or full pass cut on this. So if we simulate, what will wind up happening is I'll slow it down a little bit further this time, is it's going to come around and it's going to machine away the outside there, clean up the corners a little bit, and then it's going to bore out that inside. And when we're done with it, you'll notice that it didn't go all the way up to the line because we left that 5/1000ths of an inch for a finished cut. So we'll finish that. And to be able to finish cut that, what we want to do is we want to go to our 2D, and we are going to go to 2D contour. We'll select that. And we're going to stick with our 1/2 inch flat end mill. We'll go to our geometry, and we are going to be selecting 2 lines. It's going to be the bottom of that contour right there, and it's going to be the bottom of that contour right there. So then we also want to make sure that we click on rust machining. Actually, no, we don't need rust machining for that one. We want to go to heights then, and we're going to go to model top for everything. And remember, for our bottom height, we want to make sure that that is at -0.8, kind of like when we did our 3D adaptive clearing. Our passes, our compensation, we want to make sure that we are in the computer for this one. Our finished feed rate, we're going to slow that down a little bit. We're going to put that to 15 inches a minute to get a real nice pass on there. And we're not going to leave any stock. So linking, that looks good. We'll press OK. And when we simulate this, what will wind up happening is it's going to come in and it's going to clear out that inside, and then it's going to come on out and it'll clean up that outside. All right, the next thing that we want to do is we want to spot drill all of these holes. And what we need to do is we absolutely need to spot drill these with our 1/4 inch spotting drill bit. because if we just, especially for like our 1/8 inch, or if we start drilling our 1032 threads right there, what can happen is your drill bit can wander a little bit and you won't get a nice straight point. So we always want to pre-drill or spot drill our holes. And you're going to be able to find your drill bits under our drilling, which is right there. We're not going to be drilling with our 1/2 inch flat end mill. We'll select tools, we'll go to RFHS tool library, and we have our 1/4 inch drill right there, which is going to be tool 12. So we'll select that. And the geometry that we want to take is the inside contours of all of these. So we have our geometry, now we just need our heights. So again, everything's going to go from your model top and our bottom type. We're going to go from our model top, but we are going to just go down negative, so we can go a little bit further than 15th thou. We'll put in 20th thou, and that'll just give us the spot point for it. Right? And for this one, we're just going to be doing a drilling rapid out for that, because all we're doing is we're just coming down and we're spot drilling. We're not going to be going super deep or anything like that. We don't need to peck. We just want to get a little spot face there. So we have, next up, we're going to drill out these 4 holes on the outside. And for that, we want to select our drill. And this drill is going to be an H drill. So we'll go to Tool, RFHS Tool Library, and our H drill is a tool number 19, which is .266. So we'll select that. And our geometry, we select these tabs right there. For our heights, model top, model top, model top. And for this one, so if we take a look at it and we go model bottom, what's going to happen is it's only going to go to the bottom with the very point. Now with your angled end, that's not going to go all the way through. So I'm going to change this to model top, and if we put this at our offset at -0.9, that'll allow us to be able to drill all the way through, because we want to make sure that our shoulders are able to poke through the bottom. So for our cycle type, we're going to be drilling fairly deep. So what we want to do is we want to do a chip breaking. This isn't a super deep drilling routine, but we just want to be able to do a chip breaking. And what that's going to do is it's going to come down and come up a little bit as it keeps going down. So then what we'll do is we'll press OK. And if we do a simulate that one, we'll be able to go through and see that we already have your spot drills right there from the previous one. We'll come down and we have our 4 holes drilled. The last one is going to be one last drilling operation. It's going to be these 1/8 inch holes for our roll pins. So we will go to our tools, select our RFHS tool library, go down to 1/8 inch drill bit, which is tool 13. We'll hit select. Our geometry is going to be that hole and that hole. Our heights tab, remember we want to go to model top for everything. Except for the bottom one, what we want to do is we want to go to our whole bottom, and that will be able to get all the way down for us. Our cycle, this is also going to be a chip breaking. We'll press OK for that. And then we have our drill bit, our drilling tool path for that. All right. So we have our first operation done, and with this operation what we did is we made our setup, we faced it, we roughed it out, we came back in with a contour to touch everything up, and we drilled our 6 holes on the top. The next step that we will do is in our machine, get rid of our bit there, our machine, what we'll do is we'll flip this over and we'll put this into our vise just like that, and we'll write a conversational program at the machine to be able to face off the tops until we have our finished final top. Then what we'll be able to do is in our next video we'll show you how to run a tool path that'll cut out or drill out your center hole, and then also drill and tap these holes, and we'll be able to use that twice, once on this side and once on that side.